All right, let's dive right in. Today, we are going to build our very first Node.js function on AWS Lambda. We're going to go from a totally blank file all the way to a fully deployed and observable piece of code running in the cloud. So let's be real. You love writing Node.js, right? But the whole server management thing, the provisioning, the patching, the scaling, it's a drag. What if you could just write your code, hit upload, and let it just run? Well, that's not some far-off dream. That is exactly the promise of AWS Lambda. You get to focus on what you're good at, the actual code, the logic that matters, and Lambda takes care of all that messy infrastructure stuff for you. Okay, so first things first, we have to talk about the runtime. Think of it as the engine that actually executes your code inside Lambda. Now, for Node.js, AWS supports specific versions, and as you can see, they each have a very clear lifecycle. My advice? Just stick with a long-term support version like Node.js 20 or 22. It's always the safest bet. Now, no matter what language you're using, every single Lambda function really boils down to three core pieces. These are the fundamental building blocks: the handler, the event, and the context. So let's pull them apart and see how they work. The handler. This is the absolute heart of your function. It is the one single entry point. When Lambda gets a trigger, like an API call, this is the specific method it knows to call. You can really think of it as the main function of your serverless world. So when your handler gets called, it's not empty-handed. It always gets two things. First up is the event object. This is your payload, your input data. If it's an API call, this is where all the HTTP request details live. And second, you get the context object. Think of this as Lambda giving you metadata about the execution itself, like the function's name, its memory limit, and, this one's super useful, how much time you have left before it times out. Okay, now here's where things get pretty interesting. You actually have a choice in how you structure your Node.js code. You can go old school with CommonJS, using require, or you can use the more modern ES modules with import and export. And let me tell you, AWS has a very strong recommendation here, and for a really, really good reason. And here's why they care so much. It all comes down to performance and predictability. When you use ES modules, you get this amazing feature called top-level await. What that means is you can do all your slow, asynchronous setup stuff, like connecting to a database, before your main handler code even runs. It guarantees all of that is done and dusted first. This is huge for preventing weird bugs and for making your cold starts, that first run after a while, way, way more efficient. Okay, so you've written your awesome code. It's sitting there on your machine. Now what? How do we get this thing up into the AWS cloud where it can actually do something useful? Well, you've basically got two main paths you can take. Path number one is the classic .zip file. It's simple, it's direct, you just package your code and its dependencies and you're good to go. It's perfect for most functions, honestly. Path number two is the container image. This is the bring your own everything option. It gives you total control, which is great for really large or custom applications. But yeah, it's a little more work to set up. And look just how straightforward the zip method is. It's literally 4 steps. You write your code, you run npm install like you always do, you zip up the whole directory, and you upload it. Bam! Done. Your code is now live in the cloud, ready to go. All right, mission accomplished. Your function is deployed. But are we done? Not quite. Getting it running is one thing. Getting it running well, fast, cheap, and efficient, that's the next level. So let's talk about some critical best practices for performance. Okay, listen up, because if you only remember one thing from this whole explainer, make it this. This is the golden rule of Lambda performance. Any slow, heavy lifting, like creating database connections or initializing SDK clients, do it outside of your handler function. Why? Because Lambda is smart. It often reuses that execution environment, so that setup work only has to happen once, and every call after that is super fast. This will save you a ton of time and, yes, a ton of money. And here are a few more quick-hit pro tips. Keep your handler file clean. Put your real business logic in separate files. It makes testing so much easier. Keep your deployment package small. The smaller it is, the faster your function starts up. And always use environment variables for things like API keys. Never hard-code them. Oh, and here's a freebie. Lambda automatically enables Keep Alive on TCP connections, so you're already getting a performance boost without doing a thing. So your function is now running out there, somewhere, in the giant AWS cloud. It can feel a little bit like a black box, right? Like, how do you know what's actually happening inside? Well, don't worry, AWS gives you some really powerful flashlights to peek inside. Right out of the box, anything you write to the console with console.log or console.error gets automatically captured and sent straight to Amazon CloudWatch logs. It's seriously that easy. It is the #1 way to just see what the heck is going on inside your function when it runs.
But okay, what if you have tons of logs? For more serious debugging, you can just flip a switch and tell Lambda to format all of your logs as structured JSON. Now, why would you do that? Because it turns your logs into a searchable database. You can run powerful SQL-like queries to hunt down that one specific error in a sea of messages. It's an absolute lifesaver for troubleshooting complex issues.
So, console.log is great for what's happening inside your function. But your function doesn't live in a vacuum, right? It calls other things, a database, another API. That's where things can get tricky. And that is exactly what AWS X-Ray is for. It's like putting a tracer on your request and watching its entire journey as it flows through your whole system.
And getting X-Ray up and running is surprisingly easy. You just click a checkbox in the Lambda settings called Active Tracing, add the X-Ray SDK to your project, and then wrap your AWS clients with it. That's it. X-Ray takes over from there and starts drawing this incredible map of how all your services are talking to each other.
And just like that, we've done the whole thing. We've walked through the anatomy of a function, figured out how to write and deploy our code, learned the tricks to make it fast, and finally, saw how to keep an eye on it once it's live in the wild. That's the full developer journey from start to finish.
So now you have all the pieces. You've got the fundamental building blocks to go out and create some really powerful, scalable, and cost-effective serverless applications with Node.js. So the only real question left is, what amazing thing are you going to build next?